So good morning students, and today we are going to discuss about evaluation of double integration in numerical methods. So there are two methods we have to discuss now. One is trapezoidal rule, and one is Simpson's one-third rule. Now let's see the trapezoidal rule. Let us take integration I equal to double integral over the limit c to d a to b f of x comma y dx dy equal to h in times h into k by 4. Sum of the values of f at the four corners plus 2 times of sum of the values of f at the remaining nodes on the boundary plus 4 times of sum of the values of f at the interior nodes. So this is a formula to evaluate the double integrations when we have functions of x and y, right? So for this, we need the values of h and k. H is nothing but the lower and upper limit values of x. So h can be evaluated as h equal to the upper limit of x minus the lower limit of a divided by number of ordinates. Similarly, we can easily evaluate finding the value of k by substituting upper and lower limit values of y. Upper limit of y minus lower limit of y divided by number of ordinates, that is d minus e by n. Here we have the values of k, h and k. I have used three different colors to differentiate the values in the table. In the formula, we have three terms. One is corner values, boundary values, and interior nodes. So I have used three different colors for that. Corners indicated as red color, boundary values indicated as green colors. I've used blue color for the interior nodes. While solving the problem, you can easily understand it. And then Simpson's rule, which is better than the trapezoidal rule actually for some problems. Let us take integration I equal to integral over the limit c to d, integral over the limit a to b, f of x comma y dx dy equal to h into k by 9. Sum of values of f at the four corners plus 2 times of sum of the values of f at the odd position on the boundary except corners plus 4 times of sum of the values of f at even position on the boundary except corners plus 4 times of sum of the values of f at odd position on the odd row plus 8 times of sum of the values of f at even position on the odd row plus 8 times of sum of the values of f at odd position on the even row plus 16 times of sum of the values of f at even position on the even row. In the previous formula, we have a 3 terms. Now we have a 8 number of terms. So I've used 8 different colors to differentiate the values in the table. In the same way, we can find the value of h and k by substituting upper and lower limit value of x and y. H is defined as b minus a by n, k equal to d minus e by n. So b and a and b are lower and upper limit value of x, and c and d are lower and upper limit value of y. N represent number of ordinates. It may not be equal. You may use some other letters like m and n because may not be equal. So when you write n, it shows both are equal. So better to use some other letter. So I've used m and n here. The same way to proceed in the trapezoidal rule as well. Now let's see some problems in it. I'll tell you how to calculate the red color, how to choose the red color values, green color, blue color, and then orange color. So everything I'll tell you while starting the problem. Problem number 1, evaluate the double integral over the limit 1 to 2, both x and y. xy by x plus y dx dy by using trapezoidal rule, h and k values given in the equations directly. So no need to calculate it. H and k value, mostly they will give you in the question itself. So no need to calculate the values of h and k. If not, you have to calculate it. upper and lower limit values using upper limit minus lower limit divided by number of ordinates. You can use 4 intervals or 8 intervals, something like that. Now let's see. So this is a function. The function is xy by x plus y. Now we can calculate the table value. So table value we have to identify it. So we can write x and y either a row and column. I have written x as column and y as row. So look at the lower limit value for x and y. X and y starts from 1. So you should start from 1 and you just add with the length of the interval. Length of the interval is 0.25. We would add 0.25 here, then 1.5, 1.75, 2. Similarly, we have 1, 1.25, 1.5, 1.75, 2, because the length of the interval is 0.25. You have to add 0.25 step by step. Okay, so now what we have to do, how to calculate the table values. Okay, so when x equal to 1 and y equal to 1, we can get 0.5, right? Similarly, you can substitute x equal to 1.25, y equal to 1 in this function. We get 0.556. Similarly, you can substitute x equal to 1.5 and y equal to 1 in this function. You can get 0.6. Similarly, we can find all the remaining values by substituting various values of x and y, right? So you can find it row wise or column wise. That doesn't matter. We have to identify all the values. And here totally we have 5 rows. 1, 2, 3, 4, 5. At the same time, we have 5 columns. 1, 2, 3, 4, 5. It may not be equal. So it may be rectangular array. We can get it based on the value of h and k and lower and upper limit value of x and y. Okay, so it may not be square, it may be rectangular box, we can get it. Okay, so the thing is, we have used 3 colors in this table based on the formula. Previously we have discussed the trapezoidal rule formula, right? The first term of the formula is sum of the values of f at 4 corner values. So the corner values indicated by red color, as you can see on the screen, 0.5, 0.6667, 1, 0.6667, right? So these are the corner values I have indicated as red colors. The next thing is some of the values of f on the boundary. So boundary represent the first row, last row, first column, last column. What is first row? This one. Last row, first column, last column. Some of the values of f on the boundary except corner. Okay, so we have chosen the corner values. So you have to omit the corner values and you have to sum all the boundary values which are indicated by green color. 0.556, 0.6, 0.6364, 0.7692, 0.8571, 0.9333, 0.9333 again, 0.8571, 0.7692, 0.6364, 0.6, 0.556. So these are the boundary values except corners. Okay, so we have to add it all these things. That will be the second term of the formula. So the third term of the formula is you have to sum of the values of f at the interior node. Interior node, as you can see on the screen, the blue color indicates the interior nodes. Okay, we have to add all these values. Then we substitute all these things in the formula. We'll get the final result of the given double integral value. Now we can see here, right on the formula, trapezoidal rule is h into k by 4 sum of values of f at the four corners plus 2 times of sum of the values of f at the remaining nodes on the boundary plus 4 times of sum of the values of f at the interior nodes. Okay, now which is equivalent to h. So what are the values of h and k? 0.25, right? So h and k are 0.25 divided by 4. First term of the formula is corner values. There are four corners: 0.5, 0.667 plus 0.667 plus 1 plus 2 times of sum of the values of on the boundary, the green color values, which we have seen in the table, right? We just add all the green color values, which represents boundary values, except corners. Okay, so place 4 times of interior nodes. You can add all the blue color values, which represents interior nodes. By calculating it, we obtain the final result, integration I equal to 0.7 triple three, sorry, 3303. So you may use here, we have used 5 decimal places, better to use 4 decimal places always. Okay, so now this is the approximate value of the given double integrations values. As you can, you know very well, we are finding the approximate value, right, in numerical methods. We know it may not be exact value, it may differ. Okay, so this is the required answer for this first question. Now we can go for the second one. Problem number 2. Evaluate double integral over the limit 1 to 1.4 integral over the limit 2 to 2.4 dx dy by 1 by xy. Okay, so here h and k value is given in the question as well. If not, you can calculate it by dividing it into 4 subintervals. So h equal to upper limit minus lower limit divided by number of ordinate. You can use 4 subintervals or 8 subintervals or 16 subintervals or 10 equal intervals. You can divide it into equal intervals. It may be 4, it may be 8 or 10 or 5 or something like that. But when they are not mentioning the value of h and k, you can do it. Otherwise, no need to do it. You can use the given h and k value. H and k value is given, no need to calculate it here, right? Okay. So the first thing is to calculate the table value. I told you you should start with the lower limit and end up with upper limit. And here I've represented x columns. There are 5 columns in it. So 2, the x value starts from 2. The value of h is 0.1, so that we are adding 0.1 consecutively. So 2, 2.1, 2.2, 2.3, and 2.4. Do not write 2.5 because the upper limit is 2.4. You just end with 2.4. Okay, so start with 2 and end with 2.4. And look at the value of y, lower limit of y is 1. You should start with lower limit and end with upper limit 1.4 with the help of uh, k value 1, 1.4, 1.2, 1.3, 1.4, something like that. Okay, so now the function is 1 by xy. The function is 1 by xy. We just substitute the value of x as 2 and y as 1 here. You get 0.5. Similarly, substitute x equal to 2.1 and y equal to 1, we get 0.4762. When x equal to 2.2, y equal to 1, we get 0.4545. When x equal to 2.3 and y equal to 1, the function is 0.4348. Similarly, we can get all the remaining table values by substituting various values of x and y in the function. Right? So here we have a 5 rows and 5 columns. Definitely we should find out 25 values. 5 into 5, 25. So we are finding 25 different values of f. Okay. So after finding it, you just note down. We have to calculate three different values. What are the three different terms in the formula? Corner values, boundary values, interior nodes. So there are three terms in the trapezoidal rule. One is corner. The corner values are indicated by the red colors. As you can see on the screen, you can easily understand first term of the formula. Corner values. Second term is boundary values except corner. First row, last row, first column, last column. Right? The boundary values except corners. The third term of the formula is some of the values of f, the interior nodes which are indicated by blue colors, right? So you can easily understand the values given in the table. Now we have to substitute all these things in the formula. We can get the final result of the given double integration. The formula for a trapezoidal rule is h and k by 4 sum of the values of f at the four corners plus 2 times the sum of the values of f at the remaining nodes on the boundary plus 4 times the sum of the values of f at the interior nodes. Right? So corner, there are four corners always in all the problems plus 2 times the boundary values. It may vary. We can say 8 values or 10 values, something like that. But there will be a four corners. It may be square or maybe a rectangular values. The corner value is always four different values. It may be 0.5 plus 4, 0.4167 plus 0.2976, 0.3571. Similarly, we can choose the boundary values which are given as green colors plus four times of uh, interior nodes. Now you have to use your scientific calculator properly. Then we can get the values of the integration 0.0614. Okay, so this is the final value of the given double integrations. Okay, so at the same time, they're asking to uh, check whether verify with actual integrations. So actual integration is you have to integrate it directly. Integral or the limit 1 to 1 point. Here we have the constant limit so that we can integrate directly. Uh, Integration of 1 by y it becomes log y. Integration of 1 by x it becomes log x. You can see here log of, we have to substitute upper limit minus lower limit, log 1.4 minus log 1. You know the value of log 1, that is 0. So there is mentioned here. So log 1.4 into log 2.4 minus log 2. You should know one more thing. Log a minus log b gives you what? Log of a by b, right? So by using this, we get log 1 by 2, log 1.2. Log 2.4 divided by log 2. That is here 2.4 is a, 2 is b. So 2.4 divided by 2 it becomes 1.2. Then use your calculator. Then we can get the integral value 0.0613. I told you we are finding the approximate value of the integration. When we use actual integration, we are getting 0.0613. But when we use trapezoidal rule, we get 0.0614. There is a minor corrections in it. Okay, and it's called as error. So we are finding it approximate value of the integrations using trapezoidal rule. Now we obtain the exact solution by using actual integration 0.0613. Okay, now let's see problems on Simpson's rule. Evaluate the double integral over the limit 2 to 3, 1 to 2, 1 by 4 times of xy dx dy by using Simpson's rule by 4 subintervals. They're asking to divide it into 4 subintervals. So we know how to calculate the value of h and k. The value of the lower and upper limit value of x is 1 and 2. The lower and upper limit value of y is 2 and 3. So by using that, we can get the value of h and k directly. H equal to 2 minus 1, that is upper limit minus lower limit divided by 4, that is 0.25, k equal to 3 minus 2 divided by 4, which is equal to 0.25. So sometimes they may mention the value of h and k in the question itself, but sometimes they won't mention it. For that, you have to calculate it manually by using 4 subintervals or 6 intervals or 8 intervals. Okay, in Simpson's rule, there will be 7 terms we have to calculate it. We have to choose in the table value. We know we can easily identify how to find the table values. We can substitute various values of x and y in the function. We can get 25 values because there are 5 rows, 5 columns. So definitely there will be a 25 values in the table. The function is 1 by 4 times of xy. We can substitute x equal to 1, y equal to 2. X equal to 1, y equal to 2.25. X equal to 1, y equal to 2.5. X equal to 1, y equal to 2.75. Similarly, we can get the remaining terms of f. Okay, so well, this is a very important thing because we have 7 different terms in the formula. Previously, we have only 3 terms. That will be very easy to calculate the values. Here, there are 7 different terms in the formula. So I have used 7 different colors in the table value, and I have to tell you one by one. Okay, what are the terms in the formula? The first term is always corner values. Some of the values of f at 4 corners. What are the corner values? Red color indicates the corner values. Okay, first term completed, right? What is the second term? Consider the boundary. What are the boundary? First row, last row. First column, last column. What is first row? And this one first row, last row. First column, last column. Okay, so in that we have to choose odd position on the boundary except corner. Okay, so we have chosen the corner values. You have to neglect it. The remaining odd terms are in the first row, the green color. The green color indicates the odd position on the boundary. Odd position on the boundary. Boundary, which means first row. First row, odd position is 0.0833. Similarly, last row, odd position is 0.0555. Look at the first column. What is the odd position? 0.10. What is the odd position in the last row? 0.05, which are indicated uh, by green color, right? Okay, so next thing is, what is the third term? The third term of the formula is even position on the boundary. Even position on the boundary. First row, even position. Second position, fourth position, which are indicated by blue color. What is the last row? Even position on the last row. In here, 0.0666, 0.476. What is the first column? Even position. 0.1111, 0.0909. What is the even position on the last column? 0.0555, 0.4545. Right? So these are the odd and even position on the boundary. Okay. So first one is corner values, and then odd position on the boundary, green color values, even position on the boundary, blue color values. Okay, so we completed three terms of the formula. What are the remaining four terms? The remaining four terms are odd row on the odd position, odd position on the odd row. What are the odd row? There are five rows, right? There are five rows. 1, 3, 5 are odd rows, right? First row, third row, fifth row, which are odd rows. Here, luckily, first row and fifth row is comes under boundary. So do not consider it. First row and last row, first column, last column are boundary. So we may not take it. We may not consider it. So remaining term is third row is the only possible odd row. Third row is the only possible odd row. In that, we have to choose odd position. What is the odd position? 0.0666. 0.0666. The only one value which comes under odd position on the boundary. Okay, which is indicated as orange color. At the same time, at the same odd row, we have to choose even position. Even position indicated as purple color. 0.08, 0.05714, which is the even position on the odd row. Similarly, we can go for even row. What are the even rows we have? 2, 4. We have a 2 even rows. In even row, we have to choose odd position, which is 0.0740, 0.0606. Right? So there are two values, even row, odd position on the even row. What is the last term of the formula? The last term of the formula is even position on the even row. What are the even rows? Second row and fourth row. Even position indicated as pink color, 0.0888, 0.0634, 0.7272, 0.05194. So these are the even position on the even row. So all the values we have taken for the formula. Okay. Now we can substitute all these values in the formula, right? As you can see on the screen, here we have 7 colors we have used. Red color indicates corner values, blue color indicates green color indicates odd position on the boundary, blue color indicates even position on the boundary, right? And then this one, odd position on the odd row, even position on the odd row, and here odd position on the even position on the even row. So these are the 25 values we found out. How we have to substitute all these things in the formula, we can easily obtain the answers, right? The final value is integration I equal to 0.07019. Okay, equal to 0.07019 is the required answer for this problem. So you should memorize the formula properly. Here, first term of the formula is sum of the values of f at 4 corners plus 2 times of 2, 4, 4, 8, 8, 16. Okay, you have to add it. 2, 4, 4, 8, 8, 16. The terms are odd position, boundary, odd position on the boundary, even position on the boundary, odd position on the odd row, even position on the odd row, odd position on the even row, even position on the even row. There are 7 terms you have to calculate it in the table. And finally, we can get the integration value, right? So this is a way to evaluate the double integral using Simpson's rule, right? So we have 7 terms, so uh, better to memorize the formula properly. Okay, you do not make mistakes in this terms number. Okay, 2, 4, 4, 8, 8, 16. Okay, just keep in your mind because sometimes somebody will forget to write on the values. Okay, so it will be very easy to identify the values. I have used 7 colors. You can easily understand it. Red color represents corner values. Green color represent odd position on the boundary. Blue color represent even position on the boundary. That orange color represent odd position on the odd row. Purple color represent even position on the odd row. Gray color represent odd position on the even row. Pink color represent even position on the even row. Okay, so this is a way to find the evaluation of double integral. Okay, so in the so try to solve this problem yourself, right? This is a practice problem. Integration I equal to double integral over the limit 0 to 1 sine of xy by 1 plus xy dx dy by using Simpson's one-third rule by taking value of h and k are 1 by 4, right? So try to solve this problem yourself. In the same way we can get the result. Okay, so thank you, students.